All right, hello. Thank you all for joining us for this first webinar in the Analytics for Everyone webinar series presented by eCapital. The first webinar we'll do today is the Competing on Data Science, but we have, as you can see, we have other webinars coming up that you can go to our website and register for, and we'll talk a little bit more about those at the end of my presentation. So today, we're going to talk about competing on data science. My name is Chris Engstrom. I'm the Data Science Practice Lead here at eCapital. And today, I'm going to spend hopefully just about 30 minutes and talk a little bit about kind of data science trends in the market, trends around applied data science. We're going to go through a few, some use cases, and then wrap up by talking about how eCapital engages clients and how we approach client engagements for data science, predictive, and prescriptive projects. So eCapital, we're an established consultancy with 80 employees, teams in 14 states, $25 million in revenue, over 300 customers, and we have a broad range of services from business transformations, business intelligence, to the area I work in is advanced analytics, predictive modeling, and decision optimization. And eCapital is known for having strong long-term relationships with its clients. My background, so I actually started my career in direct marketing, database marketing. Out of college, I was building predictive models in the early 90s. I then went to Microsoft for 8 years, 6 years out in Seattle, 2 in London, and there I was in a number of roles from database analysis to predictive modeling. We did a lot of measurement design when the web and the internet were emerging in the mid-90s, and then I then moved back to Minneapolis, where I'm based now with eCapital, and I joined Medtronic, spent 8 years at Medtronic, building a number of quantitative teams. My last job there was Director of Analytics in the Cardiac Rhythm Disease Management area. I then spent 4 years consulting on my own, analytics consulting. But what kind of characterizes my career is definitely I've built quantitative functions in companies from the ground up, successful ones, and you can see my domain experience there. That's my main domain experience. But when we talk about data science at eCapital, we really want to focus on the applied data science. Data science is a huge space. There's a lot going on. There's kind of research, academic research in data science. There's applied data science. It's a large space, fascinating space, but when we engage clients, we're really focusing on understanding that these tools are just tools that we use to really improve business outcomes, whether it's saving money or increasing profit or wherever it is. So we're very focused on business understanding first before we go and define projects and pilot projects for clients. And if you've done work in the data science analytics space, you'll know that some projects are very measurable from an ROI standpoint, others are not. And some projects are very deployable, and others are very difficult to deploy. I mean, in my career, I've seen large projects that were really terrific from an insight, analytical modeling standpoint, but really were not able to be deployed in the organization because if you can't integrate modeling output into the work stream, then the project value ends with the insight, and it doesn't really kind of reach the true value to the organization. We also definitely like to take a team approach with the client's existing staff and analytical people. So I'm going to just kind of cover just a few trends that I see in data science it's a big space, and just some things that I think are notable for clients and organizations working to apply these tools. If you think about, data are now considered strategic assets, and if you've been, following media, certainly business media in the last 5 years, you'll understand that data are becoming strategic assets, not just for companies that are born into data science, but every major industry. And when I started my career, in the early 90s, it's just amazing how long it has taken for more mainstream companies to start utilizing these tools. But what I can say is I can really feel that data science is happening now, and it's happening fast. My CEO and I were on a call a couple months ago with a couple clients. They were just talking about competitive pressure. They had competitors who were utilizing machine learning, and they had to get together with a data strategy and a plan to start competing. There are transformational applications that are happening with these tools being built into existing software deployments and technologies. It used to be all about IT because, if I was doing a project, I would spend 80% of my time with IT trying to get the data, out of these operational data architectures into analytical structures that I could actually use. But, we're so far beyond the data warehouse these days that the data models available today are much more conducive to analysis and modeling. And that's great. And if we look at the growth rates in data science, machine learning, and prescriptive, it's very impressive. If we look at some kind of notable trends, right now, like the talent and the tools are kind of in flux right now. There's a lot going on in the space. Certainly from the open source standpoint, it's a bit Byzantine, the open source area now, but it's a great kind of almost academic kind of model where people are building stuff. They're putting it out there and having people peer review it and so on. So there's a lot going on. People are coming into the field from all sorts of different areas, which is also exciting too. Modern data platform is a term eCapital uses to essentially say, what is the kind of modern architecture to allow self-service access for BI, for modeling, for analysis. There are visual modelers and code-based modelers. Governance, of course, is always a foundational concern for the space. But then when we get into kind of empowering analytical staff, the tools are really fairly amazing these days in terms of augmenting data prep and modeling, and really bringing these tools and capabilities to junior analysts and above. And lastly, we'll talk about decision optimization. I'm going to talk a little bit about that later, but this is an area that is really fascinating. I think it's a very strategic area for the next 5 to 10 years for clients. So you kind of boil this down to, as data becomes strategic assets, predictive and prescriptive and data science it's becoming very quickly an essential competitive advantage. We've seen clients tell these stories. But what is the recipe for competing? Certainly, accessing a modern data platform so you can get self-service access to data for BI, for analysis, for modeling, that it can empower the staff, and really accessing these powerful tools. And the tools are really amazing in terms of data preparation, visual modeling, machine learning, open source, and automation of many tasks that would take ETL tasks and data wrangling tasks that would just take so much time before. Is now much easier with some of these tools. So if we talk about data strategic assets, we need to say, how do we unlock the value of these assets? So if we have data and we can do some analysis and create some insider knowledge, that's you're kind of like, if you run a marathon, you're at mile 20, you're kind of like halfway there. It's kind of the same thing in data science where you develop insight, you're really only halfway there, because the hard part is actually transitioning to saying, let's take this insight and create, organizational business value with it. And I talked about that before. We're very sensitive to this and focused on when we engage clients to really maximize our likelihood of creating value. If you think about common applications, obviously there are lots of applications, but general categories of how these tools are applied for organizations to create value: maximizing customer life cycles, maximizing operational efficiency, saving costs, maximizing asset allocations, resource allocations, reducing risk and uncertainty, and discovering opportunities. This is often left off presentations, but the size of the data assets and the dimensionality of these assets, in many cases, are beyond kind of the analyst's ability to analyze. And so there's tools that can really start to really bring patterns, useful patterns out of large data sets, whether data mining or knowledge discovery in databases. But these are applications that can provide value. If we look at the customer life cycle, I mean, we can break that down into customer understanding, segmentation, classification, or clustering of customers, valuing those segments, looking at them from an asset standpoint. So if you think about, you have a company has a customer database. It's a living, breathing organization. There's constantly an inflow of new customers. There's a development of existing customers, and there's an outflow as customers leave you. So, you know, you need to look at it as an asset, a living asset, to say, what is the health of this asset over time? I mean, are the new customers coming in, the net present value of those customers is higher than those that are leaving you? So then looking at development of customers, upselling and cross-selling customers, retention, and work around this and projects around this can then feed insight into the actual acquisition of customers to say, we now understand how to acquire, develop, and retain high-value customers. Now we can go actually find more of those customers. If we look at, you know, if you think about any small, medium, or large company that has appreciable data assets, these techniques are, you know, potential value to you. If we can look at, you know, basic examples of applications across various industries. So now I'm going to go through a few use cases, go through a couple short ones, and then end with a longer one. But these just give a nice example of how the tools can be applied to create value. If we talk about higher education, and by the way, on June 13th, I'm going to be giving an in-depth webinar on student attrition modeling in higher education. And if you are interested in this space, please join us on June 13th for that, and that will go into much more detail. But I don't know if higher education space is a fairly fascinating space. My daughter is a senior in high school, and she'll be off to college in the fall. So I've spent the last 4 years, you know, immersed in this college application process, and I'll tell you, it's borderline insanity. You know, kids are applying to, you know, my daughter applied to 8 schools. The Common App is an app that allows you to, you know, it's a standardized application that allows you to apply to multiple schools. But if you look at what is going into admissions in higher education, it's stunning just on the admission standpoint. But if you start to look at what's going on in higher education, outside of the top schools who can basically, you know, charge what they like, you have a lot of mid and lower tier schools that are many of them struggling because they're locked in this kind of pernicious cycle where they have, you know, if you look at demographic trends, you have, you know, fewer students applying, but you have more applications per student due to the Common App. And what happens is you have a lot of mid and lower tier schools that are really competing fiercely for new students. And what happens is this 200-year-old education model has really never had to cut costs. And so what happened is, you know, if they're competing for students, but the costs are rising and have been rising for some time. Part of it due to, you know, this arms race of campus improvements going on to attract students to the school. But then you have rising tuition to a point where it's reaching insanity for a 4-year degree. You're going to pay $280,000 for a top school. So the costs are rising. But at the same time, if you look at a number of these institutions outside of the top tier, you'll see attrition rates that are dramatic. And so we've got this kind of cycle that is very challenging for these institutions. And so what we can do is apply attrition modeling to part of this problem and do it within what we would call the student life cycle, which is this life cycle framework we use for customers, students, employees, and so on. And so if we were going to, you know, do an attrition modeling project for students, we always start attrition projects with defining the cost of attrition. And you can go online and find methodologies to calculate cost of attrition for voluntary employee attrition, student attrition. And what you find is that you have categories of direct and indirect costs. You know, so when a student transfers out of an organization, university or college, or they drop out, there's lost revenue, there's separation costs, lost room and board, the graduation rate goes down, and then you have indirect costs such as, certainly to the student, educational continuity, even a transfer to another school, there's a discontinuity in that education, there's education risk, there's community impact. If the student was involved in the college campus community and all of a sudden they leave, that impacts the students, the remaining students. We can talk about reputation impact. As your attrition rate or graduation rate goes down, that can impact the reputation of the institution, not to mention losing potential alumni donors. So if we think about if we're going to build an attrition model for student attrition, we would kind of categorize what things we think correlate with attrition. We'd say, well, community engagement. So we'd go and find variables, predictors in there that correlate with attrition. Community engagement meaning, are they joining clubs? Are they participating in social activities and so on? Those things obviously can be predictors of attrition. Financial reasons, academic reasons. Are they, how are they performing academically? Have they chosen a major by a certain semester? Housing and transportation are always important in terms of, if you can think about a commuter student versus a non-campus student, the different experience they have in their educational experience. Satisfaction, universities will give students survey satisfaction of dorms, food, professor, instruction quality, and so on. And of course, there's always personal reasons why people transfer or drop out of school. But we would build a number of candidate variables to go into models. We'd then build a series of predictive models and select one to help us here. But and I often talk about predictive modeling with people, but a number of people can't quite understand what exactly a predictive model is doing. So I created these two circles here, and people seem to respond well to these. If you think about the random circle, at any given time a university or college has, some of their active students are at risk of transferring or dropping out, and they don't have the resources to go in and check in on every single student. So the model essentially says we can find factors, data that correlate significantly with attrition. We can build a model, and what the model essentially does is it concentrates those most at risk into a much smaller portion of the active student file, which there creates some useful data for administration to then go and pursue these most at-risk students with intervention plans and custom plans to kind of get to them before and address their issues if they have them before they transfer or drop out. So again, if you're interested in this, June 13th, I'll be going into this in more depth. Time series forecasting, I want to just spend a little time on this. I mean, I studied economics, so I did a lot of time series forecasting in college. But when I moved into the working world, and I've spent a lot of time working with, especially finance people over the years, but I find, it just seems to me like such a useful tool. But I guess my experience has shown I don't see this being used a lot, outside of people who do predictive or data science. Maybe, I'm sure it's being used in some areas, but generally I just don't see as much use with it. But I just see tremendous benefits of time series forecasting. So, if I've watched, how many finance folks have I watched who are doing forecasts in Excel? And these people are Excel wizards, and they're doing straight line regression forecasts in Excel, and they're tweaking and making assumptions, but it just seems very difficult. And so one thing that time series forecasting does is it immediately it identifies seasonality. So if you have a time series that has seasonality, it identifies that and bakes it into your forecast. Time series is fairly simple deployment. I mean, it's a wide range of tools, and at its very simple series, exponential smoothing, it can be deployed very quickly. It's a very accessible set of tools that any analyst can be trained up on fairly quickly. If you're doing reforecasts, we all know my wife is an FP&A, and so when she goes through planning and reforecasting and everything, it's a big headache. And so to be able to reforecast on the fly with a push of a button is a really terrific feature of, especially if you have thousands of customers or thousands of SKUs. But And baseline, you can use it for baseline forecasts. We all know that, you know, companies have analysts and category managers that spend a lot of time, you know, building their expert opinions into their forecasts for their top customers and so on. But this is not a tool to replace all that, but it can be a baseline tool to say, let's use a time series forecast as a starting forecast, and then let your experts, analysts, and category managers kind of put their expert, you know, forecasting insight on top of those forecasts. So it is a way to kind of use a standard method, reset your kind of forecasting approach based on time series instead of just spreadsheets. Market interventions, so if you think about time series forecasting allows you to input market interventions into your forecast. So what that would mean is if there's like a regulatory change in a market, you could put that into your model. If there's, you know, competitive activity going on, you can integrate that into your forecast. If you're doing, you know, marketing spends or, you know, marketing push, that kind of stuff, those are all things that can be incorporated into your forecast models. If you look down on the lower left, I mean, if you had 1,000 customers and you know, your top 10, 20% of your customers generate most of your revenue, and you've got people focused on those, but you have lots of other customers who maybe their lifetime value is lower, but you still need to kind of forecast their revenue. You can use time series to, you know, essentially do what we would call change detection, because when you use time series, you get this upper and lower spec, which just kind of identifies the normal variation in, you know, customer activity over time. And so you can use that to say, you know, as a change detection system to say, you know, if one of these customers that we're not, you know, looking at every day or every week, if, you know, they break one of those specs, either in a positive or a negative way, it can throw a flag and an analyst can go look at it. So another use for this, again, if you have 10,000 SKUs to forecast, you know, this can really be a time saver in terms of, you know, the push of a button, do simple series forecasts of these SKUs, and then, you know, customizing them as needed. This is a technique, it's ROI measurable, so you could actually kind of go back in time and test this against your expert forecasting, your existing forecasting system. And you know, it's a very basic, it provides a visualization that you can start overlaying other series to start understanding what is going on in a market over time. You can do what's called multivariate forecasting, so you can actually bring in predictor series that build essentially a regression model to predict your target series. And weather data, you know, we all know that weather has an impact on many businesses, whether it's a monthly, weekly, daily, or hourly. And weather data just is well suited. It could be kind of added as a series into these forecasts, and not just to improve your forecast, but actually to give you some insight and explanatory insight into what's happening with customers, markets, or products. Okay, let's talk a little bit about decision optimization. So I think, you know, decision optimization is basically defining an objective and then, you know, defining constraints around limited resources and then optimizing that objective. And this has been around, again, for decades. I think, you know, there's been a lot of, you know, operations research PhDs and Fortune 100 companies doing this for a long time. But, and again, these are not predictive methods, but they're really essentially saying that every organization has limited resources, and they have to allocate resources. And if you think about resource allocation, it becomes complex very quickly. So think about like a small business that has, you know, 15 employees, and they're trying to schedule these employees, you know, across, you know, a week or something. A simple exercise like that can get very complex for a human brain in a spreadsheet to calculate. So the point is that businesses can get very complex very quickly in terms of the resource allocation. And these tools now, with the data environments and the tools, are now kind of providing, can now provide value to really companies of any size. And I really, as I've been looking into this more and more, you know, this is just a tremendous area for, you know, strategic opportunity for companies in the next, you know, 5 to 10 years. So talk about, an example of what decision optimization is. IBM refers to it as prescriptive analytics, so it is different from predictive. And if we look at this diagram, basically, if you think about business intelligence and reporting, it's kind of like rear view mirror data. It's like what happened, it's descriptive data. This car metaphor here, it would essentially represent, what is in the rear view mirror. Now, when we start to forecast and build predictive models, we're attempting to forecast the future. And so the corollary here in the metaphor would be that, the car is looking at the amount of gas in the tank. It may be accessing our previous driving patterns, and it's predicting that we have 228 miles left on our tank. So that's kind of the predictive forecast in the metaphor. So what is the prescriptive thing? So the prescriptive thing is, say, if we're going from point A to point B, and we look at the million possibilities on the map where we could actually get there, and if the car has access to traffic data, construction data, essentially weather data, it can then, all of a sudden we have a very complex optimization problem. And the optimization algorithm then says, takes those data, optimizes the solution, gives us this action plan to say this is the best route from point A to point B at this point in time given traffic, construction, and weather. And if we look at industry use cases, as I mentioned before, I think there are lots of applications across various industries. So I'm going to wrap up the use cases here with an employee attrition example. So we're talking about voluntary employee attrition, but as we can see, employee attrition is an important issue to organizations. And however, this research shows that only about 13% of organizations are actually doing predictive talent retention. And I've done this in the past, and it is a terrific application of predictive analytics, not only because the cost of attrition can be calculated conservatively and measured against your incremental reduction of attrition, but it's a really fantastic application, and as you can see in this study, it's showing it's very underutilized. If we think about back to this life cycle idea, we want to maximize the employee life cycle. And if we think about where we could apply predictive analytics to the employee life cycle, there's engagement, which is a huge topic for, organizations, that they're engaging their employees in their work in the organization. There's workforce planning, valuation of the workforce, valuing the asset, the value and the health of the workforce over time. When you talk about employee impact analysis, so we know that not all employees have the same impact on the business as others. If certain employees are interacting with top high-value customers, and the impact that employee has is very high relative to someone else in the organization. Development analytics, you're bringing in people to invest in them and get really develop them as really strong contributors. And then recruitment, all this kind of analysis can then feed back insight into the actual recruitment process. But I just want to, we're going to go over kind of attrition modeling. So the benefits of predicting employee attrition, basically the idea is that you're using a model to marginally reduce the attrition rate in a subgroup of employees. So, and that lowers the cost of attrition. But the process itself, it really generates a lot of insight around employee understanding that can inform, recruitment, the workforce planning, and engagement. And so we'll move back to our familiar slide. This time we'll be looking, instead of students, we'll be looking at employee attrition. Again, we're talking about voluntary employee attrition. And the idea, again, is that an organization at any point in time has employees that are at risk. And HR and management can't be checking in with everyone in a custom way. So what we do is we calculate the cost of attrition. Again, we find, and I've done this in the past using very conservative financial estimates, and the cost can be staggering. And one research study shows that it can be 1.5 to 2 times salary in terms of the total fully burdened cost of attrition of a single employee. If we look at the direct costs of separation costs, vacancy costs, these are HR terms. Recruiting costs, relocation, onboarding, training. I mean, I worked in the medical device industry, and I'll tell you the amount of training those people have to go through, highly skilled, highly experienced, knowledgeable people around very complex devices. I mean, the amount of training that goes in is very high, as in many industries. If we look at indirect costs, you know, position productivity is down when someone leaves. That means team productivity is down. It can affect team morale, lost knowledge, customer impact, competitive risk as people walk out the door with all the tribal knowledge of that organization. So, you know, again, we would then say, what are our predictive categories? These are different for employees. We look at engagement, managerial issues. We've all had good and bad bosses. Bosses can have a serious impact on attrition. Alignment, I mean, is this person's skills and experience aligned for the role they're in? And is that role, you know, aligned with the team they're on? Is that team aligned with the strategy of the organization? There are always personal reasons why people leave a job. You know, spouse gets transferred to the West Coast, and, you know, they leave. There are performance issues as well, especially how they're performing relative to their peers. And so we would, you know, bring these various features of variables together, build some predictive models, and then again, as we previously saw, kind of concentrate. So we can look at a graph that kind of gives an example of what the model does. So the idea here is that if you look at the red line, and the x-axis would say, if you look at 20% of the employee file, you would expect to find 20% of those at risk. And if you look at 40%, you'd expect to find 40% of those at risk. So that's the random result of just having the file. So when you apply the predictive model to the file, it concentrates those most at risk at the top of the file. So what it allows management to do is say, we can look at 10% of the file, and that should contain 31% of the employees that are most at risk. And we can go to 20% of the file, and that would contain 61% of the employees at risk. So the idea is that the model, here's where the model becomes useful, because it can concentrate in a much shorter list those most at risk. And then that data can be integrated into a BI report, a dynamic dashboard. So if we look at, we have the employee number on the left, you can drill into that employee to see the full detailed risk profile based on what is in the model, based on other variables that were in the analysis. But then we say, you know, some just basic information. This is an example of what a management report might look like. So the employee, you would look at the tenure. If you've ever built attrition models, you know that tenure is very powerful across a number of areas. The employee's manager, and then we kind of look at these predictive categories to say, of those predictive categories that I mentioned earlier, you know, where is this particular employee at risk, right? So, you know, if we talked about alignment, you know, are they on teams that are really maximizing their, you know, passion, skills, and experience? Manager risk, you know, people who, you know, employees who have low tenure with a manager are at higher risk just because, you know, it's a new relationship that they're working through. Or a particularly difficult manager can really increase attrition risk. And the commute distance, you know, you hear these stories, you talk to people commuting an hour and a half each way, and anyone can imagine how that can have a profound effect on attrition. And so the idea is that this is useful information that can be given to management, HR, and they can then build custom employee intervention plans based on those categories of risk. You know, for example, you know, the commute review, you know, working at home once or twice a week to you know, make that employee's life and experience easier. But this is an idea of applying predictive and how the results are actually used to create value in an organization. And then lastly, getting back to this life cycle concept. So we take that attrition model, and when you do an attrition, when you do it in a modeling process, there are lots of steps, and each of these steps kind of throws off value and insight. And so just the data preparation, you know, univariate, multivariate analysis creates insight that can be, you know, used, and that's just, you know, in preparation for modeling. Feature interaction detection is looking at how different variables combine. So all this insight kind of can get fed back into this life cycle, to then create other analytics and predictive projects that integrate. And as we can see, engagement, retention, recruitment, it's all integrated in some way or related, dependent, and to feed these results and start, a structured life cycle approach to this really starts to become strategic. All right, so I'm just going to wrap up here with just a few thoughts on how we approach engaging clients with data science. We know that every client is in a different spot when it comes to data science. So from a capability standpoint, their existing capabilities, their beliefs, their motivations, and their barriers. So, we may, a company may be very strategic. I've been in companies where they spend tens of millions of dollars on data science, but certain parts of the organization don't get access to those resources. So companies can be very advanced, but areas that are much less advanced. And then there are companies who they're just trying to get started. They're starting out. They're just trying to find a way forward and so on. So eCapital is very sensitive to kind of where they are, and we can really thoughtful about how we integrate, or not integrate, but how we engage with you in terms of our role. Because sometimes the company may want to do advisory work where they need a roadmap. Others just want another project person on the team. So our roles really depend on where the client is. How to take action. So we like I said, we're really focused on understanding the business and applying these tools to creating business value. We have what are called jumpstart assessments. So this is just a short engagement where it's a capped cost of $10,000 to limit the risk to the client to say, hey, why don't you come in? Let's do some whiteboard sessions. Let's do a structured readiness assessment, a project assessment, identify projects and roadmap, and a way forward for teams. And if we think about the solutions we like to focus on, we've talked about customer lifecycle modeling, time series, higher education, employee lifecycle, decision ops, and these are the kind of different modules that exist within those kind of solution packages. Lastly, it's kind of the approach, doing an assessment, creating a roadmap, and then executing, deploying, and making every effort we can to measure ROI in a project, and then continuing on with that roadmap in terms of this is our framework, our process of doing projects and engaging clients. So I'm going to end there, and thank you all for joining us for this first of our Analytics for Everyone monthly webinar series. And this was recorded, so you can access this presentation on our website or pass it on to your colleagues. But I do want to also encourage you to join us for the rest of the webinars in this series. Thursday, May 31st, the next one is conducting a $5 billion merger with Planning Analytics. I've seen this presentation. I saw it at the Think conference in Las Vegas. It's really, really a terrific presentation, great client story. And then on Wednesday, June 20th, Analytics Transformation with Francois Ross. Francois is just a fountain of terrific insight in the BI and analytics space. So please consider registering for those webinars, and you can do that at our website. So I'm going to stop there and say thank you.